This video is on geometric sequences. So a geometric sequence is when you multiply by a constant value called a common ratio to get the next term. So the important part to know is that we are multiplying. So if we say dividing by 5, that is the same thing as multiplying by 1 over 5. So you need to know that these are the same, and that for geometric sequences, we want to say multiplying by 1/5. Also, they are exponential. So that is also important to know. So we want to determine whether each sequence is geometric. If so, find the common ratio and the next 3 terms. So it's very similar to how we did it with arithmetic, except instead of subtracting, we're going to be dividing. So I'm going to take the second term and divide it by the first term, which gives me 12 divided by 8. I get 1.5. Okay, if I test another 2 numbers from the sequence and I get the same thing, then yes, it's geometric. If not, then it's not geometric. Okay, so I'm going to do A3 divided by A2. So A3 is 18 divided by 12. I get 1.5. So yes, it's geometric. The common ratio is 1.5. And then I need the next 3 terms. So I'm going to take 27. I'm going to multiply it by 1.5. When I do that, I get 40.5. I multiply by 1.5 again, I get 60.75. I do it one more time for the third term, I get 91.125. So that would be my final answer for this one. On number 4, same concept. I need to find the common ratio, or just to make sure it's geometric. So again, I'm going to take this second term and divide it by the first term, so 125 divided by 625. I either get 1/5 or 0.2. Doesn't matter which one, they're the equivalent. Okay, when I take the third term of 25 and I'm divided by 125, I get the same thing, 1/5 or 0.2. It doesn't matter again. So I'm going to find the next 3 numbers. So yes, it's geometric. My common ratio R is either 0.2 or 1/5. Again, it does not matter. So I could have 1 when I multiply that by 5, not by 5, by 0.2 or 1/5. So 5 times that would be 1. I multiply 1 by it, I get 0.2 or I get 1/5. I multiply by again, I get 0.04 or 1 over 25. Again, it doesn't matter. You just need to know how to go from a fraction to a decimal. Explicit formula. So we have an explicit formula. We've seen this before with exponential functions. Remember that a times b to the x is very similar. We have a sub 1 times r to the n minus 1 power, where a sub 1 is the first term, and r is the common ratio. And n is the term number, so if it's the 5th term, 6th term, 7th term. Again, this explicit formula is super important. We're going to use it a lot throughout this unit, throughout this topic. So make sure we know it. The recursive formula, again, very similar to arithmetic, but instead of adding, we're multiplying. So I have a sub n minus 1 times the common ratio. Again, a sub n minus 1 is the previous term, and r is that common ratio. So the next example is we just want to write the explicit and recursive formula for the geometric sequence. So I have -5, positive 10, -20, positive 40. So one thing you need to notice is that if it's going back and forth between the two, positive to negative, then that means our common ratio has to be negative. So what do I multiply negative 5 to get positive 10, that's a negative 2. And then I need my first term, which is just negative 5. So I just plug it into the formula. Explicit a sub n equals the first term, negative 5, times the common ratio, negative 2, to the n minus 1 power. Because that common ratio is negative, it needs to go in parentheses. Recursive formula, a sub n equals the previous term, a sub n minus 1, times the common ratio, negative 2. And that's it. Now this one, number 2, requires just a little bit more work, okay, because it gives us the 7th term in the common ratio. Well, good thing we know the common ratio. We just have to solve for a sub 1. So we're going to plug it into the formula. So we have a sub 7 equals a sub 1 times r to the n minus 1 power. Well, we know a sub 7, which changes this into a 7. So we have 4 is equal to a sub 1 times 1/4 to the 6th power. Well, 1/4 to the 6th power, it's a messy decimal, so it would be best to have it as a fraction, which would be 1 over 4,096. To get that out of the denominator, I'm going to multiply both sides by 4,096. Both sides by 4,096. When I do that, I get 16,384 is my first term. Those cancel out over here, and that gives me that. So my first term, I know it. I know my common ratio, so the explicit a sub 1 equals 16,384 times 1/4 to the n minus 1 power. The recursive a sub n equals the previous term times 1/4. And that's it. Okay, finding the nth term of the geometric sequence. So with these, the numbers get really big or really small really fast. So you just have to know how to change your calculator from a fraction to a decimal. So off to the side, I'm going to write that step if you have a TI 30XA. So TI 30XA, and it says it at the top what calculator it is. You're going to change it from a decimal to a fraction. You just hit the second button, and then at the bottom, right below it, the very last row, you will see an arrow button that looks like that. Above it, you will see it says fraction to decimal. If you're using a TI 84 plus or a TI 83, you will just hit that math button, and the first one says frac, the second one says decimal, and that's how you switch it back and forth. Okay, so finding the nth term. So number 1 is from the equation above, so I'm going to just use that explicit formula. So the explicit formula was a sub n equals a negative 5 times a negative 2 to the n minus 1 power. We want to find the 9th term, so a sub 9, oops, changing colors. A sub 9 equals negative 5 times negative 2, 9 minus 1 power. 9 minus 1 is 8. Negative 2 to the 8th power, that's going to be a positive number, which is 256. I multiply that by negative 5, I get a negative 1,280. And that is my 9th term. Okay, number 2, I want to find a sub 7. I need to know my first term, which is 1,024. And I need to know my common ratio. So how am I going from each one? Again, if you're not sure, take the second term, divide it by the first term, get a decimal or a fraction. You should either get 1/4 or 0.25. It does not matter which one you use. So we plug it in. We want to find the 7th term. So my first term times my common ratio to the 7 minus 1 power, which gives me the first term, and I changed that number of the first term. Good thing I caught it early before we solved everything. That gives me 6. So when I take 1/4 to the 6th power, I get 1 over 4,096. and I multiply them together, and I just get 1/4 or 0.25. So either one of those would be accepted for the 7th term. If it's multiple choice and you see only fraction answers, change all the fractions to decimals. If you get a fraction answer and all the answer choices are decimals, just change your fraction to a decimal. Top divided by the bottom. Okay, moving on to the second half, we want to find the missing terms. So we got to fill in the blank. But what we know the first term. We don't know the second, third, or fourth, but we know the 5th term. So we're going to kind of use the formula as we need it, like we did with arithmetic sequences. So I'm going to say a sub 5 equals the first term times the common ratio to the n minus 1 power. We're trying to find r. We know the 5th term to be 10. We know the first term to be 810. We don't know r, but we know it's to the 5 minus 1 power, which is 4. So I'm going to go ahead and rewrite that. R to the 4th. Now, the 810 and the r to the 4th are being multiplied, so I'm going to divide both sides by 810. So when I do that, I get 1 over 81 is equal to r to the 4th. To get rid of that exponent of a 4, I do the inverse by taking the 4th root of both sides. When I do that, I get 1 over 3 equals r, which means I'm multiplying by 1/3 or dividing by 3, if that's easier to do. So 810 divided by 3 or multiplied by 1/3 is 270. 270 multiplied by 1/3 or divided by 3 is 90. 90 times 1/3 or divided by 3 is 30. And then if I check that, if I multiply 30 by 1/3, I get 10. So it works out. So again, I took each one of these and I multiplied by 1/3, which is this, not 1/4, 1/3, which is the same thing as dividing by 3. So as long as you understand that, it's not going to be too bad with the fractions. Okay, so same concept with number 2. I know the first term. I need to fill in the second, third, fourth term, but I do know the 5th, so I'm going to plug it in the same way. So a sub 5 is 2.5. My first term is 640. I'm trying to find r, 5 minus 1 power. And you just go about solving it. It's the same steps all the time. We just plug in different numbers. So I'm going to divide by 640 on both sides. It's going to give me a fraction or a decimal. I'm going to leave it as a fraction because they're usually perfect ones. So I get 1 over 256 to the r to equals r to the 4th power. Again, 4th root both sides, the inverse to get rid of that exponent. When I do that, I get 1 over 4 or 0.25 equals r. So I'm going to just multiply by 1/4 each time. So 640 times 1/4 is 160. 160 times 1/4 is 40. 40 times 1/4 is 10. 10 times 1/4 is 2.5. So I filled in the blanks. Okay, the last 2 examples, we want to find the nth term given the 2 terms that we have, which is no problem. So we're going to start by finding r. Again, we're going to adapt the equation to make it do what we want it to do. So I'm going to have a sub 7 equals a sub 5, because that's the first term they give me, times r to the 7 minus 5 power. Again, I'm just changing the explicit formula to work for me. So I changed the n's to 7's for both of them, the 1's both to 5's. So I plug in what I know. So I have 384 is equal to 96 times r squared. I divide both sides by 96. Oop, it went backwards. Divide both sides by 96. I get r squared equals 4. I square root both sides. I get r equals 2. Okay, now that I know r, I can find the first term. So we have a sub 7 equals the first term times common ratio 7 minus 1. Again, if I change the 1's back to, if I change the 5's back to 1's, I have to change it in both spots. So I do 384 times A sub 1, that's what I'm trying to find. R, we said, was 2 to the 6th power. So now that I know that, 2 to the 6th power is 64. So I get 384 times a sub 1 times 64. Divide both sides by 64. Should be an equal sign right there. When I do that, I get 6. So I know R, I know the first term. Now I can solve for the 10th term. So the 10th term, a sub 10 equals the first term times the common ratio to the 10 minus 1 power, which is 6 times 2 to the 9th. 6 times 512, 2 to the 9th, that's what it equals if you put in your calculator. You get 3,072, 10th term. Okay. Last but not least, we want to find the 8th term. We're given the 3rd and the 5th. Same concept that we did. We're going to start by solving for R first. So I'm going to do a sub 5 equals a sub 3 times R to the 5 minus 3 power. So the 5th term is 324. The 3rd term is 36. R squared. Divide both sides by 36. You get R squared equals 9. And the square root of both sides, R equals 3. Now that I know R, I can solve for the first term. So that's a sub 1. Let me fix that. Said a sub R. A sub 1 times R to the n 5 minus 1 power, because n is 5. 5 minus 1, and I changed it back to a sub 1. So I have 324 equals a sub 1 times 3 to the 4th power, which is, fix that real quick. So 324 equals a sub 1 to the 81st, or equals 81, not 81st, sorry. I divide both sides by 81. When I do that, the first term equals 4. Now that I know that, I can find the 8th term. So a sub 8 equals a sub 1 times R to the 8 minus 1 power. So I have 4 times 3 to the 7th power, which gives me 2,187 times 4, which is 8,748. And that would be my 8th term. Okay, so this is the video on everything you should know about geometric sequences.